The country. Home sweet home. 155 acres of the quiet life. Enough country to run some cattle. Grow your veggies. Fruit trees. Serenity. This is John Jenkin.
This is QGC. It's Kenya. BG Group. Kenya Fields. These are my neighbours. The worst neighbours you could ever have.
So what's it like?
Like a nightmare. Doesn't stop. 24 hours a day. Roaring, screaming, traffic, compression stations, smells. It rains and it doesn't smell at all. Yeah, what can I say? Sick kids. They don't sleep. When they do sleep, they moan and groan all the time. When they're awake, they pretty much do the same. It's either pain or taste, I suppose. Aaron continually whinges for something to eat, something to drink, trying to get rid of the taste in his mouth. This is my son Aaron, and why we're doing this is because it's his future. We bought the farm for somewhere for him to have for the rest of his life. Aaron was born with quadriplegic cerebral palsy, extra sensitive hearing, and a fast metabolism, which all work against us at the minute. He hears the machines miles away. QGC know this. They have a report from the Cerebral Palsy League stating 3 years ago the things they should do, at least some soundproofing of the house. Still waiting. They have done nothing except for run us in circles and cost us money and health. Yasmin, well, she's come to the point where she sits in a room all day and just doesn't go anywhere. No friends anymore, shone from the community.
Being forced out of town, a town the kids went to school in and were popular in, to now where no one acknowledges them at all.
Why do you think that is?
But yes, I don't know. I'd say that yes, a lot of the influential people around the town have probably been signed up by the gas company. And yeah, you
Our
keep...
friends and neighbours have, yes, and they have rung and told us that they can no longer come here and we can no longer go there because they have signed contracts.
With QGC.
Yep.
So it's easier, once you sign their contracts, it's easier not to have visitors.
So confidentiality agreements?
Oh yes, they're good at that. Because if I sign mine, I've got to restrict anybody that comes here to what they say when they leave, about what they heard, felt, smelt, or witnessed the whole time they were here. So for government departments to come, I would have to have my own confidentiality agreements drawn up for anybody to sign that came. Even the therapists for my son, my daughter, and we have sometimes 3, 4, 5 a week, which would be a cost to have them drawn up.
Very few people understand what this is like, do they?
No, I would say, yeah, unless you live in it, you have no idea. It's like, yeah, I'd say like a disability family. We always say in the disability sector, if you don't live it or very closely associated with somebody with it, you won't understand it. And the gas field's pretty much the same. But unless you're involved, you don't understand it or don't want to understand it. All you see is the ads and say it's a good thing, unless you live in it.
I had an asthma-induced heart attack back in May, and I was sent to the PA hospital in Brisbane for a week. I was in a ward with 6 people. 3 of those were gas company workers. Brett Smith sat at our dinner table, told my family this could be a life-changing experience.
This is Brett Smith with North Burnett Mayor Don War. Here he is pictured with Oswald Brothers staff in an article by Coal Seam Gas News titled Rural Queenslanders Are Collateral Damage, QGC. Brett Smith, the Senior Vice President of Sustainability in the BG Group that owns QGC. Mr. Smith replied that there would be no moratorium and no buyouts, no relocation of impacted residents. Mr. Smith reportedly added, with a project of this size there will be some collateral damage. In QGC's own literature, where you can in fact get the facts, an article titled QGC to Connect Rural Families with Specialist Medical Services. Brett Smith said the project reflected QGC's commitment to rural health services. Community health is a key focus through which we manage social impacts and maximise benefits from our Queensland Curtis LNG project, Mr Smith said. Vehicles on John's property clearly indicate there's something in the air around the gas field, and yet the question remains. Impacted landholders desperately want to know, what is it on the roof of our cars, on the roof of our houses?
We only live about 4 kilometres away from a reverse osmosis plant. The wind always blows from that direction, the noise comes from that way, the bad smells seem to come from that way. And maybe that's where it comes from.
What's the government told you?
It will be sorted out in due course. Complain, no help.
So while workers are being moved out of the gas fields, it's common local knowledge that workers in the gas industry do not drink local town water. Their drinking water is supplied, free of charge. John then agrees to show me more of his neighbour's more recent developments.
The more canyon ponds. On top of a reverse osmosis plant. Pumping station. Oh, they've taken away the main entrance. So they moved it down further, right? Must have their new one open. Such a good safe industry, why do they need so many gates and fences?
Air pollution and noise pollution from unconventional gas constitutes harmful, unlawful trespass. I'm asked by people, how can I help? Get informed. Share this video and other non-industry and non-government information about the unconventional gas industry.
I've got photos of when we've washed it beforehand, and yeah, now it's lost all the paint on top of it. It's got oil running off it every time it rains. Don't know what it is. No one will come out to test what's in the air, what's in the water, but we have to live in amongst it while they hide the truth from us. We have to suffer the illnesses while they hide the truth from us. It won't be long and it'll be affecting your children.
A degree in environmental biology. I worked for the last 30 years in the oil and gas industry. I still do, but of course, speaking out, I get very little work. I did wildlife monitoring in oil and gas development areas in the tar sands, as well as in a natural gas field in the northwest of Alberta. We did a 10-year cumulative effects assessment project in the Chinchaga area of northwest Alberta, which was my big passion. And my business did a lot of cumulative effects assessments, environmental impact assessments, and consultation with First Nations communities, guides, trappers, the people who would be affected by these developments.
Okay. All right, well, go ahead. So you worked for, did you originally work for the company that is doing a lot of the fracking?
Yes, I wasn't an employee. I consulted to Encana for quite a few years. I worked for Pan-Canadian. Encana was merged between two big companies in Alberta, and one of them was Pan-Canadian and one of them was Alberta Energy Corporation, and they both have their own interesting history. Alberta Energy Corporation was actually tormenting people in northwest Alberta and northeast British Columbia, and there's a big story there, but they were caught with the RCMP, the Royal Canadian Mounted Police, and blowing up one of their own gas wells to try to frame a concerned landowner. And so that history comes into Encana. My history with the company was I worked a number of decades for Pan-Canadian, and I always thought they were a much better company. When the two merged, it was as though the good in the company vanished and all the evil came out, bigger than ever before.
What, okay, so the evil came, what are the examples of that evil?
Well, the promise of we are a good neighbor while coming in and abusing communities, dividing and conquering, promising a little bit of money, embarrassingly tiny little bribes in Alberta. In America, at least the people expect and get millions. In Alberta, the people sell themselves out and their children and their community for a few $100,000. It's incredible to me. And then using that little bit of money to feed into the dark side of human nature, which I've really found fascinating to observe, and then using that to prevent communities from staying cohesive. Communities used to take care of their own. Now, with this new unconventional oil and gas, what I'm finding the companies have learned, no healthy community will allow hydraulic fracturing. So they have to make the community sick. And they do so by feeding the dark side of human nature, which is greed, sloth, selfishness. They feed the ego, they promise a little bit, and then whammo, the community's divided. The people with concerns are then abused by the people who want more money. And Canada doesn't even have to do the dirty work. A lot of the other companies, the people in the communities do the dirty work for them. It's an incredibly brilliant technique. It works very well. Everywhere they're fracking, this is happening. And my conclusion as a scientist and as an environmental biologist or environmental specialist that has worked in this industry, my conclusion is that no healthy community on this planet would allow hydraulic fracturing because it is not safe. It is impossible to do, even with the best rules and regulations. Industry said last night here in Michigan that the rules here would prevent what happened to us in Rosebud, Alberta, because there are no coal formations here. That's ridiculous, because nobody knows what they're going to end up doing, deep or shallow, in Michigan. And regardless of what formations there are or what type of shales, industry always uses the excuse, oh, no, but what happened in that terrible instance over there, that horrible pollution that happened there, that'll never happen here. But it always seems to. And the impacts are the same, and industry knowing that the impacts are there.
Can you cite examples of what you just said, where they've gone in and said, well, we're not going to, that's an isolated problem. We won't have that problem here. Can you give any examples?
Oh, yes. In Alberta, in America, in the early 90s, they began doing experimental fracking for coal bed methane. And it was deeper. And the companies there created terrible pollution, and lots of aquifers were compromised, many water wells. And there was a massive class action lawsuit in the early 90s. And the United States Geological Survey did a multi-year study by Chafin. He concluded that nature was not the culprit for gas migration, and that man-made fractures and activities caused most of the near surface gas in the area. The class action lawsuit settled out of court, unfortunately, and sounds like, from what the lawyers have stated, with confidentiality agreements. So when this process began in Alberta, while Encana was already experimenting in my community in secret while lying, our politicians and industry were having these big circus show meetings promising, oh, what happened in America will never happen in Alberta. Oh, no. We're going to be far deeper. We're only going to be far below where the drinking water is. Oh, we have the best in the world regulations. No, what happened in America will never happen here in Alberta. We won't let it. We have world-class regulators. We won't allow the noise. We won't allow the dust and the road degradation and the destruction of communities. We will not let we will not let companies break the law. But they did. So now here's a Canadian coming to Michigan, and I find this fascinating. So we have in the 90s Americans devastated by coal bed methane development. They start this development with hydraulic fracturing in Alberta. They promise us it'll never happen to us what happened in America. I'm coming to Michigan. I've been invited to come here to warn people in Michigan. And industry says, oh, no. What happened to you will never happen here. But it already has, just in a different state.
Hello, I'm Professor Tony Ingraffia from Cornell University and President of Physicians, Scientists, and Engineers for Healthy Energy. Over the next few minutes, I'm going to summarize the best available science on the question of the intersection between the development of shale gas, natural gas, methane, and climate change. I'm going to summarize three things. Number one, is there a significant amount of methane leakage, emission into the atmosphere during the process of shale gas development? Two, does that leakage have a deleterious effect on climate change? Does it make climate change worse? And three, if it does make it worse, do we have a viable alternative to increasing the development of this fossil fuel, shale gas, natural gas, methane? So let's get started. Everybody knows that natural gas is a clean fossil fuel. We're told that every day, every place from the president to our local newspapers. What's the implication of calling a fossil fuel clean? Clearly, it doesn't mean that it doesn't produce carbon dioxide. All fossil fuels produce carbon dioxide when they're burned. Natural gas, shale gas, methane, produces less carbon dioxide than its sister fossil fuels, oil and coal. But the implication here is that because it's clean, it's good in our battle against climate change. And the further implication is the only thing we have to worry about is one of the greenhouse gases produced by burning this fuel or producing it, and that's carbon dioxide. I want to change your opinion about that. We all know the story about carbon dioxide. Over the years since the Industrial Revolution, humans have burned coal, oil, and natural gas in prodigious quantities, and we continue to increase the rate at which we're burning them. Therefore, we keep increasing the rate at which we're putting carbon dioxide into the atmosphere, and that is the principal cause for ongoing climate change. We know now that the rate at which carbon dioxide is increasing is about 2 parts per million per year, and that means that within 30 years, not 100, but within 30 years, we're going to get to that unfortunate limit of 450 parts per million, which all climate scientists of any repute say means that we will have changed the average Earth atmospheric temperature by about 2 degrees centigrade. Interpreted, that means we're in bad trouble. But carbon dioxide is not the only greenhouse gas that's produced when fossil fuels are mined, transported, and burned. There is another greenhouse gas that's produced, and it's methane. And legally, according to a Supreme Court decision that declared carbon dioxide a pollutant that causes climate change, methane is also a greenhouse gas that causes climate change. Why is it then that we only ever hear about carbon dioxide? We only ever hear about carbon dioxide from the president, from large environmental groups, from the media. Is that the whole story? And the answer is no. So why should we be concerned about methane? Methane is a much more potent greenhouse gas than carbon dioxide. Simply put, it means a molecule of methane has more heat trapping capability than a molecule of carbon dioxide. Well, the next science question is by how much? And the answer is, it depends upon how long you're willing to wait to make that comparison. If you're willing to wait 100 years to compare the effect of one molecule of methane to one molecule of carbon dioxide, then that one molecule of methane has about 33 times the heat trapping capability as one molecule of carbon dioxide. That's pretty bad. But we don't have 100 years to wait. If we're willing to only look at 20 years and make the comparison between methane and carbon dioxide, then the latest science says that that factor is over 100. It would take 100 carbon dioxide molecules to have the same heat trapping capability as one molecule of methane. And there is the important science issue. That means that a very small quantity of methane emitted into the atmosphere without being burned is very, very bad for climate change. It exacerbates climate change. It effectively means for every 1% of the gas that's produced from a shale gas well that is emitted into the atmosphere without ever being burned, that's the same thing as if you did burn it twice. Where does the methane come from? How does it get into the atmosphere? How is it emitted? It's emitted both by accident and purposefully by the industry operations. Here is a list of the principal ways in which methane is emitted into the atmosphere from shale gas production. During drilling, during the flowback period, when the fracking fluid comes back to the surface, along with large quantities of gas at high pressure and high flow rates, continuously at the pad site by way of wells that leak, and I'll show you a video of a leaking well in a minute or two, during a process called liquid unloading, during the gas processing, separating methane from propane, butane, and during transmission, storage, and distribution through pipelines and storage facilities, including potential liquefied natural gas facilities. So those are the epochs, the periods during which methane can be emitted, purposefully or accidentally. I'm going to show you a few videos of some of those episodes. So first we're going to go to a well pad where there is flowback occurring. The well has been drilled, it's been fracked, and as you can see from this standard still image, gas is being emitted. In this case, it's water vapor. But I'm now going to show you a video where we're going to replace a typical photograph with what's called a forward-looking infrared video, which is able to detect different gases by way of color separation. Let me start the video for you. What you're seeing in this video in false color is the emission of large quantities of methane, natural gas, during the flowback period of a well that has just been hydraulically fractured. Everything that's yellow is methane, natural gas. As you can see, there's large quantities being emitted, and those emissions occur over days, sometimes up to a week or more. So hundreds of thousands of cubic feet of methane are being vented into the atmosphere to become a greenhouse gas, which over a short period of time is 100 times more potent than carbon dioxide as a climate change agent. Let me show you another image, another video of how methane can leak, and it's from leaking wells. Wells that have lost their ability to contain the hydrocarbon in the steel casing, which you'll see in the center of this video. Again, I'll start the video for you. This bubbling is occurring in a pool of water that's accumulated around the wellhead. This is methane and perhaps other hydrocarbon gases leaking from outside the well and getting into the atmosphere. This occurrence is not uncommon. Data from Pennsylvania in the last 3 years show that this kind of leaking occurs in about 1 out of every 20 brand new wells. Industry data shows over time that that kind of leakage begins to occur much more frequently as the wells age. So those are two examples by video of how methane is emitted into the atmosphere without being burned and becomes a very potent greenhouse gas. Let's go all the way downstream. We've left the well pad, we left the processing station, we left the compressor station. The gas has been transported by a transmission pipeline to Boston, and it's now being distributed through pipelines under the streets of Boston. This image shows a comparison of the methane concentration in the atmosphere along the streets of Boston to what would be the normal background level. Everybody breathing on the surface of the earth right now is breathing on the order of 2 parts per million methane. But this graph shows that along many of the streets in Boston, the concentration of methane in the atmosphere is 10 to 15 times the background. Conclusion, the pipes are leaking. The pipes are leaking methane. So throughout the whole process, from the time a well is drilled to the time the gas is distributed to homes and businesses, there's the potential for methane leaking into the atmosphere. How much leaks is a critical technical question. So we go to the recent literature. 2 years ago, colleagues of mine at Cornell University, Professor Bob Howarth and our technical support staff, Renee Santoro, published a paper in which we estimated, without any measurements, just estimated on the basis of best available data at that time, that somewhere between 3 and 8% of all the gas produced by a shale gas well would never get burned. It would be emitted into the atmosphere through mechanisms like the ones I just showed you. Scientists around the world are now taking our suggestion from that paper from 2 years ago and going out and actually making measurements of leakage. 2 recent results show that in Utah, up to 9% of all the methane being produced by gas wells out there was being leaked into the atmosphere. In Colorado, anywhere between 2.3 and 7% was being leaked into the atmosphere. And remember, over 20 years, a 1% leakage rate is really significant. So these actual measurements are cause for concern. In our paper 2 years ago, we made predictions. And we estimated, based on our predictions, that shale gas, at best, was worse than coal or diesel oil in its effect on climate change. The horizontal axis here compares shale gas, conventional gas, coal, and diesel oil when they're produced and when they're burned in terms of the carbon dioxide they produce and the methane they produce. The vertical axis is the impact on climate change. The larger the bar, the worst. So our estimate was at least this amount was leaking, and as much as this amount was leaking. And we're about to find out over the next few years, because of scientific investigations where measurements are actually being made, like the ones I just showed you, that the answer is probably going to be somewhere in that range. When we determine that conclusively, scientifically, and we're convinced that we will, we're going to see that shale gas is not the cleanest, not the least worst of all the fossil fuels. It's the dirtiest. It's the worst. So any transfer of using coal or oil to natural gas is going in the wrong direction. It's not helping climate change. It's making it worse. I want to show you the latest computerized simulations and data of where carbon dioxide, methane, and black carbon are taking us with respect to climate change. So the three principal human-made components of climate change are carbon dioxide, methane, and black carbon. Let's see what the latest science says. BC in this picture is black carbon. So the horizontal axis is year, from 1900 to 2070, and the vertical axis is the relative temperature change of the Earth's atmosphere. We all know about the fact that global climate change means global warming. So anything above zero is an increase in the average temperature of the Earth's atmosphere relative to some baseline value. The squiggly line are actual measurements. This is data collected all around the world. And as you can see, the data show that the average Earth atmospheric temperature is increasing. It's up to about 0.8 of a degree centigrade warmer than it was a century ago. These four curves are computer simulations. They predict, using the best available science, the largest supercomputers and the smartest people in climate science, what we're liable to see under different scenarios. We have a choice. We can do certain things with these fossil fuels. We can choose not to do certain things with them. If we choose business as usual, increasing the rate at which we're burning fossil fuels, the computer models say we're on that purple line. And it says we're going to get into a danger zone where we've changed the temperature by 2 degrees centigrade by about the year 2045. That's not 100 years from now. It's only about 30 years from now. If we had started in 2010 to drastically decrease the amount of carbon dioxide we're emitting into the atmosphere by drastically decreasing as rapidly as possible the burning of fossil fuels, we only delay getting into that red zone by about 2 or 3 years. By 2050, bad things will be happening. James Hansen, perhaps the most famous of all climate scientists at NASA, has predicted that when we get to that 2 degree centigrade change, we're going to see 4 to 9 meter rises in the oceans around the world. That's just one of the bad things that will happen if we get to that temperature change level. If, on the other hand, we had started in 2010 to substantially reduce the amount of methane and black carbon that we're emitting into the atmosphere, we see an immediate benefit. We delay getting into the red zone until about the year 2070. So it's much more effective in the short term to fight climate change by reducing methane and black carbon than it is to reduce carbon dioxide. Obviously, we want to reduce all three. And the computer models say, had we begun to do that in 2010, we would have been on this light blue curve. And according to the computer models, we'd never get to that 2 degree centigrade temperature change. We'd give our kids and our grandkids a fighting chance. So where does all the methane and black carbon come from? Various sources, but certainly shale gas is one of them. As I showed you, in the production of shale gas, the processing of shale gas, the fracking for shale gas, the transmission of shale gas, methane gets into the atmosphere unburned. This photograph shows you black carbon, soot, being emitted from a processing unit. That's a facility, this one's in Pennsylvania, where the methane is being separated from the butane, propane, and ethane, and the waste product is being burned in a flare. That flare burns almost continuously, and while it's burning, it's emitting large quantities of black carbon into the atmosphere. So at all levels, production, processing, distribution, transmission, storage, an unacceptable amount of methane and black carbon are being produced because of shale gas activity. What does it mean? I already indicated that according to Dr. Hansen, we can anticipate very, very large levels of change in the ocean levels by mid-century. Not in 2100, but by mid-century, 30 years from now. We're already seeing an effect, another effect, which is the loss of the Arctic ice cap. So this is the most recent data from NASA, which shows here the average extent during late summer of the coverage of ice in the Arctic. That's that yellow curve. That's the 30-year average. This is the actual satellite photograph of what it looked like in September of last year. Computer models say, variously, depending upon which model you're looking at, we will completely lose the Arctic ice cap anywhere from 10 to 30 years from now. We lose the Arctic ice cap, we lose a large reflector. That's called albedo. That white ice is reflecting heat back into the atmosphere and back into outer space. We lose that, we now have blue. We're absorbing heat. We absorb heat into the ocean, we do two things. We raise the average temperature of the ocean, which increases the volume of the ocean, which raises sea levels. We also decrease the ability of the ocean to absorb carbon dioxide out of the atmosphere. You'll note that, unfortunately, oil and gas companies are seeing this, which is an unimpeded, almost unimpeded path through the Northern Passage, to ask their governments to increase the amount of oil and gas production in the Arctic Ocean. That's called burning your candle at both ends. Finally, I want to say something about the alternative that I promised at the beginning of this talk. We don't have to increase the production of shale gas everywhere. We certainly don't even have to start it in New York State. There's a much better alternative. So in March of 2013, a group of engineers, scientists, economists, investment bankers published a paper after 2 years of working on it, which shows that there is a viable plan to convert New York State from the use of fossil fuels completely to the use of non-fossil fuels within 20 to 30 years. So I'm going to briefly summarize what that paper finds. It's a peer-reviewed, refereed journal publication paper. It's not a report. It's not a blog statement. It's bona fide science. We own the wind. You own it, I own it, the Russians own it, the Bulgarians own it, the French own it, everybody owns the wind. Same with sunlight, same with water. We don't have to fight each other for it. It gives every country the opportunity for energy independence and energy security. And moreover, the fuel cost is zero. We don't have to pay an oil or gas company for sun, for water, or for wind. Therefore, it is economically feasible to transform our energy sources in New York State entirely to wind, water, and solar in just 2 or 3 decades. It's economically feasible, it's technically feasible with the technologies that we have today. We don't have to wait for new inventions. We can use the wind turbine, the photovoltaic capabilities, the geothermal capabilities, the hydroelectric capabilities, the biofuel capabilities already on the books. And by building this much wind, water, and solar infrastructure in New York State, we can convert New York State completely to a non-fossil fuel usage state. Other states obviously can follow. If New York State can do it, if Germany can do it, if Denmark can do it, other states and other countries can do it. So we have a clear choice in New York State. If we're really concerned about climate change, as I'm sure you are, we can as quickly as possible involve our legislators, our regulators, our investment banking community, and every individual citizen to get started on this. Or, as the oil and gas industry would like us to do, we can get started on that. 50 to 100,000 shale gas wells in the Marcellus and Utica formations in New York State, which would mean 8,000 to 16,000 pads, each of them with many wells, 500 to 1,000 compressor stations with their noise and gas emissions, thousands of miles of new pipeline, meaning destruction of forest cover, thousands of incidents of well water contamination from leaking wells. We would increase New York State's contribution to global warming, not decrease it. We would continue the illness and morbidity from pollution from burning fossil fuels. And here's something no one's ever written about. All that steel that goes down a shale gas well, allegedly to protect our water resources, all that steel, if we build 100,000 wells in New York State, we will be sequestering forever twice the equivalent tonnage in steel of the United States Navy underground forever. Once it's down there, you can't yank it back up and recycle it. That's a waste of human resources. It's a waste of the resources from our children and our grandchildren. I'm putting my money where my mouth is. So as I just indicated, it's up to every citizen in New York State to get out and do something. They can do it in their own homes. They can do it in their own cars. They can do it in their communities. So here in Ithaca, New York, where I live, I was one of the initial investors in the Black Oak Wind Farm. Within a year, we're going to have a 40-megawatt wind farm right outside of Ithaca, New York, and that's a community activity. A few hundred citizens got together, pooled their money, and are doing something significant for New York State, for climate change, and for all the people on the face of the earth. So let me conclude by saying what I've already intimated. Given a choice between shale gas and the inevitable emission of methane and black carbon from shale gas activities, which we now know will not make climate change stop or slow down, it will make it speed up, or doing something that is obvious, wind, water, and solar, I'll conclude by saying again, we own the wind. We don't have to fight for it. Same thing with sun and water as energy sources. They will make us energy secure and energy independent. It's really up to each of us to begin to work in our own homes, in our own communities, to inform our legislators and our regulators from local level through state level to federal level to recognize that carbon dioxide is not the only thing we should be concerned about. Methane is at least as important, and in some cases more important, in terms of quickly slowing down climate change. Thank you very much for your attention.